Hello, I'm Dr. Mary Johnson. I am the pioneer of the approach SILMA, Success in Learning Math Approach. SILMA has been used with many students throughout the country and outside of the United States. The main components of Soma are that to learn any math, any subject in math, you need to have 3 questions answered, and many of you have heard me talk to you about these questions as we go along. What are the numbers in this topic, whatever topic we're going to talk about, whether they're rational numbers, whole numbers, you know, we've gone through that. And then you have to know what are the operations, and that's very important because we don't just want to know addition, subtraction, multiplication, division, but we want to make sure we understand what those operations are and how to perform them. And then the last thing is the last component of these 3 questions is what are the math laws? As you know, this is the way I teach. You must have a law for every process that you do in math. And after that, then you can really learn whatever topic it is that you're trying to learn. And in the system, we start with a topic, we have objectives, we do a diagnostic test, you know about the diagnostic test. Then we have lessons, math laws are always there, examples, practice problems, and the last thing some of you have gone through is the certification of mastery test. And that takes one objective that you missed, had instruction on, and then you get a little quiz on it, 4 or 5 questions, and you show that you really know it. And that's the essence of what we do. And it doesn't matter what topic, what subject, we use those same principles for SILMA. And it has been very successful. Okay? We're going to look at adding fractions in a little slightly different way than many of you have learned and have forgotten and learned and forgotten. But this way, I believe you will always remember. We're going to start out with, of course, the math law for adding fractions. And what do you think that law is? It's you can only add fractions that have the same number where? In the denominator. Good job. You can only add fractions that have the same denominator. 4/5 plus 1/5. We can add 4/5 plus 1/5 because they have the same denominator. But when we add this, we have 4/5 plus 1/5, and everybody knows it is 5/5. And 5/5 is equal to what?
1
1. 1. 5/5 is equal to 1. And when at the law, give you another math law. First law I just gave you was you can only add fractions that have the same denominator, right?
Yes.
Second law, we can write fractions for every division of an object. The only qualification is you must have the object divided into equal parts. That's a key word that many of you miss that. You have to have equal parts when you add fractions. So when we have 5/5, that means we have the entire object. 4/5 plus 1/5 equals 5/5. And whenever we have the same number in the numerator as we have in the denominator, we know that we have divided the object into 6 equal parts, and we have the whole part, so it's equal to what? 1. That leads us to a very important law. 6/6 equals 1, 5/5 equals 1, 8/8 equals 1. The law is if the numerator and denominator are both equal in the fraction, then that fraction equals what? 1. Now, the next law you need to know is when you multiply a number by 1, 1 times 10, you get the same number. When you multiply a number by 1, you get the same number, 10. Okay. So this enables us to change any fractions that we have to any denominators that we would like to have by multiplying by a form of what? A form of 1. Yes, a form of 1. We can change the denominators. So whenever you're given fractions that have unlike denominators, you can change it. by multiplying by a form of 1, and you're not changing the value of the number. No more than you're changing the value of the money when you go to the store, go to the vending machine. You want to put in what? $1, but this machine needs a quarters, and so you may have to go and get quarters, okay? But the 4 quarters is going to equal to what? The same $1. Okay, so let's look at this. If we want to add 2/3 plus 1/3. We know the answer. Everybody got it?
1.
3/3, 1. All right. Now let's look at this one. 2/5 plus 1/7. The denominators are not the same.
Oh my God.
You cannot add the numbers this way. What do you have to do? You have to change each one of these to get equal same denominators. A fast way to do this.
Multiply the denominator.
No.
Common factor.
But how do you do that? No. Let me tell you. Wait. We're going to take the denominator of one of the fractions and form 1. And what would that be? What's 7 over 7? 1. We're going to form 1. 7 over 7 equals 1. We're going to form 1. And we're going to multiply 2/5 times 7 over 7. Did we change 2/5? No. Did we change 2/5?
No.
The form, but not the what?
Value.
Right. We're going to take 5 and write the denominator over here and write the form of 1, 5/5. And we're going to multiply what?
1/7.
1/7 times what?
5 over 5.
5/5. Okay. Now we have. Are we sure to have like denominators?
Yes.
Yes, because we made sure. We made sure we had. Because anytime you're going to use the same denominators, change to a form of 1, you're going to have the same denominators. You don't care about numerator, just denominator. All right. So now we have.
14.
You know how to multiply? We multiply fractions. Numerator times the numerator. 14.
Over 30.
Denominator times denominator.
35.
35. 1 times 5.
5. 35.
7 times 5.
35.
Why is 5 times 7 equals 7 times 5? What?
Because you just switch the numbers.
The commutative law. Some of you already know that. The commutative
Commutative.
law. Commutative law. We're not going to worry about the name right now, but I want you to know it. And so we get 5 over 35, and now we can add the fractions. 14 plus 5. I bet you
19.
anything. I bet you Mackenzie can tell you what that is. You got it. 14 plus 5, Mackenzie.
I know that.
Mackenzie.
You said 15 or 14?
Mackenzie.
19.
19. Mackenzie just came out of kindergarten a couple of months ago. 19 what, Mackenzie? 35ths. 19 35ths. Now, sometimes you will get a fraction that you can simplify. But you already know how to simplify. You form the forms and you see how many ones you have. 1 times 1 times 1 times 1. And you get the final answer. Okay. Now, I want to make sure you have this. So, the next thing is what? Practice! Woo! The next thing is practice. You have your lesson. How long is the lesson?
3 minutes.
3 minutes. Lesson 3 minutes. Got the math laws? You know the math laws?
Yes.
And now we do examples. I've done examples and now you do practice. Okay? 5 questions. 5! Your certification, we always give you 5 questions because that sort of makes it up a little bit. All right, let's do these really fast. I'm coming around to see how you do it. Those who get 100%, I have an award for you. Okay.
Come on.
This is not,
Bring it on.
now this is unusual, isn't it?
Okay.
You don't get
What's the
awards.
prize?
I better get it back.
A knowledge
Can you be
isn't
quiet and just
More
let her
than
do
that.
it?
Let's
$1?
do it. All right, the prize is do it. How long do you think it'll take you to check?
2 minutes.
2 minutes.
No, not
Less than
2
2 minutes. Less than 2
Oh,
minutes.
less.
Okay, let's do
Thank
this.
like 2 seconds.
Who said that?
Mackenzie.
Mackenzie. Give her a paper. Anybody got an extra paper? Thank you. Okay, you know the final question will be a little bit harder, you know that. All right, here I come, ready to check. Ready to check? Ready to check? All right, come on, Mackenzie. Let's go. 9 into the 5 questions. Let's go.
1/3 plus 1/5.
All right, I'm ready to check.
You just got finished writing the question.
I know, but I'm just checking to see how
Is
you're
that an
doing.
8? Oh, yeah.
Yeah, how you doing? Can you see?
Hey, we can second.
Okay.
Hold on.
All right. That's my 4. And then you get 4 8. 4 over 8
Excuse me, can I get some water?
plus 4 plus what? 4 over 8. Yes. Go ahead.
For number 4, is that a 7 or 1? 7 over 9.
7.
Okay.
7 over 9. I guess I'm going a little fast there. Fractions are numbers that consist of a whole number and a fraction. And what happens is, we've been talking about a whole divided into equal parts, but you could have more than one whole, okay? You could have more. You could have 5 oranges, right? Divided into how many parts? 5 parts. You could.
You could.
In that case, you have a mixed number. You have 5 oranges divided into 5 parts, divided 25. So you have what? 5 fifths plus 5 fifths plus 5 fifths plus 5 fifths. How many fifths do we have?
5, 10, 15, 25. 20.
5,
10, 15, 20.
Oh, I just did 4. So it's 20 what?
Over 20.
20 over what?
20.
20 over what? We added like fractions. What do we have? Fifths plus this plus this plus this gives us what?
20 over
Fifths.
5.
Gives us fifths.
I finished.
Okay, because we don't have time to put them on the board. I may have to take a little time here. Okay, great. All right. That's the 15. Okay. Is that, what's that? 6?
No, that's a 3. 3. Oh, wait, no, that's a 15.
Is it 15?
Yeah.
Oh,
It just,
it didn't look like a 15. Okay, that's fine. Okay, it looks like you're going along fine here. And you know what I'm looking at? What am I looking at?
Process.
Process. You got it. I'm looking at the process. Because what do I get for the answer? 1 point. What do I get for the process? 99%. Because the process enables you to do more problems. Whereas you get one answer, you have one answer. Got that? If you have a process done, you can do all the problems. You finished?
check the 1.
Okay, what I'm going to have to do is I'm going to have to take up your papers, put your name on it, and I'm going to make sure you get a prize.
Well, I got a prize.
Okay, I know. You. It's brave of you to try, Mackenzie. I know. All right. So, all of mathematics, you can learn mathematics. You know why? Because all of mathematics, when it is taught, so that you see the connections, the relationships, the laws, you understand what you are working with, what are the numbers. One of the reasons that students add numerators and denominators and everything else is that they never understood what addition is. Addition. And most of the textbooks I've looked and searched, so why do they tell the students? You can only add numbers that in the same category to get a collection of that category. Now you said, well, why can I add apples and oranges? 2 apples plus 3 oranges. Well, what's 2 apples plus 3 oranges? If you put them in the category of fruit, then you could have a collection of what? Fruit, and you could add them. It's like getting the right denominator, please. Don't let them come in, Dr. Williams. Who is that? And you all are witnesses, because I work with all of you on something, and you are witnesses. Anybody want to say a statement? You want to tell about your transformations? They were so hard, weren't they? Reflections and translations. It was hard. Reflection was,
No, not really.
I'm telling you, it was the one that really helped with that. But Robin, what did you have an issue with?
What did I have an issue with?
Miles, while she's thinking.
I had an issue with geometry and properties.
Okay, but now you know that you have the index cards, you know the process.
Yes.
You're going to put all those theorems, axioms, corollaries on cards, right? And you have that, and when you try to do a proof, you're going to say, I can prove this if I can prove, I need this to prove it, I need that to prove it. And then you're going to look for it in the given and the laws that you know, right? And you're doing extremely well, extremely well. And Zion, you have any questions, any issues that you've been helped with? You've pretty much been on task, right? Okay. Well, I think that all of you have had good experiences. I've worked with some of you from a very early age, right? Yes.
Yes.
Very early years, because that's a great thing about working here in the Tennis Foundation. I get to see the students come in grade K, go all the way through, graduate, come back and help us. Many of the students you see around here who were in the tennis program before, I taught them in grade K. Taught them math in grade K, right here, not here, but in the Tennis Foundation organization where it was located on 16th Street. We've only been here 3 years. Now, since we've been here, notice what's happened. Some of you have no issues, no problems, because now you are operating, what, 2 and 3 grades above grade level? Aren't you?
Yes.
How many grades above grade level? 2, I think it's 2, 3. 2 or 3 grades above grade level. In your last diagnostic test and in your last standardized test, you're operating way above. All of you have shown great progress. We have several students who are 4 and 5 grades above grade level using Soma. So we've had great success here, and I've also gone around the country teaching in other states, and students in other states, and teachers in other states. And we find that Soma works. Soma does work. What do you think?
Soma does work.
Soma does work. What do you think, Robin?
It works.
Soma works. And does it take a long time? Because they used to say, well, how long is this going to take? And I said, well, 2 or 3 minutes. I can't believe it's going to take only 2 or 3 minutes. And then, what happened, Antonio? What happened? 2 or 3 minutes. And you said, I got it. And they went to the lab. And after they get it, they practice. Sometimes they practice with me, sometimes they go to the computer lab, and they can practice on problems in the computer, But the next thing I knew, A on the test.
Oh, yeah.
A on the test. Okay? And this is an issue I have sometimes because my students will go from F's to A's so rapidly that the teachers can't believe it. What'd your teacher say?
Oh, I don't know.
Huh? He didn't say anything?
No.
But sometimes teachers get a little absurd because they can't believe that the student has made, well, he was making F last week. He came on the second test. Somebody must have helped him. What happened? He couldn't have done it on his own. But what has happened is you learn the laws. You learn the laws, you learn how to apply them, you practice, and you had someone to observe you as you practice and to correct anything that may have been a problem. Thank you, young people. I always enjoy working with you. Enjoy teaching you all the time, one-on-one, group, whatever. It's always my pleasure. And we always have what?
Fun.
Fun. Okay, thank you.
Thank you, Dr. Johnson. Thank you, Dr. Johnson.
Thank you for being here. I really enjoy it. Okay, thanks so much.